Jai Hind everyone. Today we will see some daily life examples of the equilibrium and we will try to understand what happens in stable equilibrium, unstable equilibrium and neutral equilibrium. In our daily life or in the day to day, we often see the vehicles passing by us. Many vehicles are overloaded and sometimes we find the vehicles are turned off the road because of the heavy load. What happens actually? They do not follow the conditions for the equilibrium. That is a one cause of the accident of the vehicles on the highways or on the roads. So here we will understand the complete equilibrium conditions with the help of simple activities. And for demonstrating the activity, I am taking very simple things which are easily available. The water bottle, you can see one water bottle is completely filled with the water, another water bottle is partially filled with the water, and few geometrical shapes. These are the few geometrical shapes that we are taking here. And now with the help of these shapes, I am going to describe the stable equilibrium, unstable equilibrium and the neutral equilibrium. First, the things that I am going to say, listen it carefully and observe it. See here, these are the two bottles. Easily you can see the bottles are at rest, bottles are at equilibrium, means the net force acting on the bottles are zero. Now stable equilibrium means when I displace a particle or a system from its equilibrium position and it regain its original position, then we call it stable equilibrium. The same thing I am going to do. The bottles are at equilibrium. Now I am just disturbing them. Just you see the inclination. Both the bottles are inclined at some angle. Now I am leaving the bottles and see what happens. This bottle falls down, this bottle restore the position. It means this bottle was in stable equilibrium and this bottle was in unstable equilibrium. Observe, the same I am going to repeat. Both the bottles I am displacing, I am inclining at the same angle. Now just you see they are nearly at the same angle and now I am leaving. One bottle is restoring the position, another bottle has fallen down, could not restore. Means this bottle is at stable equilibrium, this bottle is at unstable. Now let's find out what is the reason. The very easily you can see and you know also the water level is much higher here than the water level here. What happens because of this? Because of this, the total mass concentrated of this water bottle you can observe or you can notice to be here, and its height from the reference or that is the ground is nearly 8 centimeter to 10 centimeter. Whereas in this bottle, the total mass is concentrated at this point nearly, and this height is nearly 5 centimeter or 4 centimeter from the ground. So here, applying the formula of mgh, a simple formula of potential energy mgh, you can see the potential energy, or simply I should say the energy in this bottle is much more than energy in this bottle. It means to be a system in stable equilibrium, its energy should be minimum, and to be in unstable equilibrium, the system should have maximum energy. Now you can see some other examples as well. Now just you guess, there are the two things I am taking. These are the two things, nearly of the same height, but the shapes are different. Obviously, then the mass is also different. Now I am displacing them from their equilibrium position by the same amount of the angle nearly. Now I am leaving them. This cone has restored the position and this cuboid has not. It means the cone was in stable equilibrium and this cuboid was in unstable equilibrium. Again the same situation. Now if we look for the mass of the cone, so mass of the cone will be assumed to be concentrated nearby somewhere here, which is nearly 3 centimeter above the ground, and mass of this cuboid is at its geometric center here, and this is nearly 4 centimeter or 5 centimeter from the ground. It means this cone has less potential energy or less energy in comparison to this cuboid, and that's why this cone is in stable equilibrium and this cuboid is in unstable equilibrium. So be clear, to maintain a system in stable equilibrium, the body should have minimum energy, and for the unstable equilibrium the body should have maximum energy. So be aware of the vehicles which are overloaded, don't pass by them, because the energy of those vehicles are very high and they are running in unstable equilibrium. Now on the next I am going to discuss neutral equilibrium. Now just you see this cylinder, I have kept it in this way. Now I am displacing either here or here. There is no change in its energy. Now just you see its total mass can be assumed to be concentrated over here. So you can see this is the position. Now if I am displacing, again the position of mass is at this place. Again I am displacing, position of mass is at the same height. It means the energy of the system does not change if the system is in neutral equilibrium. So this is an example of neutral equilibrium. It cannot change. One more thing we are going to see. This bottle you had seen was in stable equilibrium, and now I am turning it. Now let's see what happening. I am displacing it. It is falling down. Now just you see, I am displacing it. It's coming back. Now you find the cause. Try to find the cause why it is happening so. The same bottle is giving the different result.